Good morning guys, welcome to Mind Your Math. Today our class is about how to solve linear equations in a single variable. Now that unknown variable in which the linear equation is expressed can be an x, a y, an z, a p, any of one of the 26 English alphabets. Our task is to find the value of the unknown variable as given in the equation. Now here I will be following a single method, or I will be explaining the steps that you have to follow in solving any of the linear equations, any type of the linear equations in a single variable that is given to you. Whether it is having fractions, whether it is not having fractions, multiple brackets, whatever be the equation, follow these steps to solve the linear equation. Sometimes the linear equation that is given to you would be very simple as the first one, a little more complicated as the second one, and pretty much complicated as the third one. Or you can get even more complicated questions which will involve multiple brackets or multiple terms in the denominator. Whatever be your linear equation is, follow the method that I will be explaining to you in the class, so that it is very easy for you to solve any kind of linear equations in a single variable that is given to you. That method is called fraction, bracket, transpose. I will be explaining to you this particular steps in detail, so that by the end of this class you will be adept in solving any linear equation in a single variable. Before we start a new game, we first learn the rules of the game before we learn how to play the game. We understand the rules, we accept the rules, and we learn the rules too, right? In the case of a linear equation too, there are certain rules that has to be learned before you start solving the linear equation. Okay, let me get to the rules. You know what a seesaw is, right? I think most of you have played seesaw in the park. This is the hinge on which seesaw is resting. So in order for this seesaw to be in a horizontal level or to maintain the balance, the weight on this side has to be equal to the weight on the other side. Even if we take out a weight on one side, the balance will be gone. If we add an extra weight on one side, the balance will be gone. So how do you maintain the balance? If you take out an extra weight here, the same weight has to be taken out from the other side also. Our linear equation is also like a balanced seesaw. Okay. Now there is an equal to sign, and on the right hand side you have got the RHS terms. On the left hand side you have got the LHS terms. Now you must be familiar with the usage of terms of an algebraic expression and a linear equation. So the right hand side terms can be any term, a constant or a variable term. Same with the LHS terms. Now the first rule of the linear equation say that you can add or subtract the same term on the LHS and on the RHS. Which means that if I am adding a term on the LHS, I have to add the same term on the RHS. That is a better way to put it. Or if I am subtracting a term from the LHS, the same term has to be subtracted from RHS to maintain the balance of the linear equation. Right? The same logic is with multiplication and division also. If we are multiplying the LHS with any term or any number, you have to multiply the RHS also with the same term. Same in the case of division. If you are dividing LHS with a particular number, the same number has to be divided in the RHS also. Right? Let me give you an example. Suppose you have a linear equation. Suppose you want to add a term 5 here. I am adding a 5. The same 5 has to be added on the RHS. If you want to subtract a 5 from here, the same 5 has to be subtracted from the RHS also. You want to multiply the linear equation with a 10. Whatever be the reason. I hope you have understood the first rule of how to solve the linear equation. Okay. Now, the second rule or it is more like a warning. Do not multiply or divide by a 0. Multiplication and division by a 0 is not acceptable. Okay. What is the reason? When I am multiplying with a 0 on both the sides, my linear equation will disappear. You get a 0 is equal to a 0, and when you divide by a 0, you get infinity is equal to infinity, which is kind of a very weird thing to get from a balanced linear equation. Now, let us move on to the next rule. The next rule is basically about transposing. You know what is transposing or shifting of terms. When you are transposing terms from the RHS to the LHS or from LHS to the RHS, please mind the signs. Change the sign before you transpose your terms to either side of the equal to sign. Here I have written down the rules. Add, subtract, multiply or divide has to happen on both sides of the linear equation. If you are transposing terms, please mind your signs. Okay. Do not multiply or divide by a 0. And there is one more rule. It is not a rule. It is basically again it is a small warning that there will be occasions when you will be required to multiply or divide both sides of the linear equation with a variable term. It is unavoidable while solving linear equations. But suppose you are getting a very simple linear equation of this type. Just because you can multiply or divide with a variable term, please do not do this. The reason being, once you do this, then my linear equation becomes what equation? It becomes a quadratic equation. The entire type of the linear equation has changed. My linear equation now become a quadratic equation. Now my linear equation has got a single solution. My quadratic has got two solutions. So this kind of multiplication where it is not required, please don't do. Just for the fun of it, don't do. Now let us start with the steps on how to solve the linear equations. We are done with the rules. Add, subtract, multiply, divide has to happen on both sides. Transpose, mind your signs. Two simple rules. You can easily remember them. Let us get to the steps of fraction, bracket and transpose method of solving linear equations. So, I have written down the rules of fraction, bracket, transpose. Fractions. When you say fractions, the first step when you get a linear equation is please check whether the linear equation has got any fractional terms. I say any. Even one term is fractional. Yes, this particular step is applicable. So first step, check for any fractional terms. Suppose you have got fractional terms. Check how many terms are there in total on LHS and on RHS. If there is only one term, just cross multiply. Okay. If there are more than one term, suppose the linear equation has got multiple terms on LHS and RHS or only on one side, but other side has got only one term, doesn't matter. If there are more than one term on either of the sides, take the LCM of all the denominators, right? And using that particular LCM, multiply on LHS and on RHS. Okay. Now, suppose there are no fractional terms. You move on to the step 2. Bracket. After doing those steps, you have to open all the brackets. Now the third step. Transpose the variables to the LHS and constants on the RHS. Shift your variables to the LHS and constants to the RHS after minding the signs and then solve. I will explain to you this method in detail by doing multiple sums so that you get a better understanding of this particular method. Okay. Let us start following the method of fraction, bracket, transpose by the sum that is given to you. 3 minus 2x by 5 plus 4x is equal to minus 2 by 3. Now, what was my first step? My first step was, are there fractions? Yes, of course there are fractions because even the term on the LHS and the term on the RHS both are fractions. So yes, I have fractions. How many terms are there on the LHS and on the RHS? I have got only one term. On LHS I have one term and on RHS one term. So what was my method? Cross multiply. So I cross multiply. So what do I get? 3 minus 2x into 3 is minus 2 into 5 plus 4x. So my first step is done. What was the second step? Open all the brackets. So 9 minus 6x is equal to minus 10 minus 8x. What was my third step? Transpose all the variable terms to the LHS and the constant terms to the RHS. So plus 8x. Okay. What is minus 6x plus 8x? It is 2x. This is minus 19. So what is the value of x? So we have got the value of x as minus 19 by 2. Let us do another sum in which we will involve multiple fractional terms. Now here we have the second sum. 3t minus 2 by 4 minus 2t plus 3 by 3 is equal to 2 by 3 minus t. Okay. Now let us follow the fraction, bracket, transpose method. First step. Check for fractions in the given linear equation. Are there fractional terms? Oh yes, I have got multiple fractional terms. Is there only one term in the LHS and one term on the RHS? No, I have got multiple terms on the LHS and multiple terms on the RHS. So what was my method? Take the LCM of all the denominators. So what is the LCM of 4, 3 and 3? My LCM of 4, 3 and 3 is a 12. Multiply with the LCM every single term on the LHS and the term on the RHS. So it will be 2 into 12 into 3t minus 2 by 4 minus 12 into 2t plus 3 by 3, 12 into 2 by 3 minus 2. Now, open the brackets is my second rule. Open the bracket, what do I get? 9t minus 6, 8t minus 4 into 3 is a minus 12. 12 into 2 by 3, what do I get? 12 into 2 by 3 will give me 8, right? Minus 20. What was my third step? Transpose all the variables to LHS and all the constants to the RHS. So 90 minus 80 plus 12t is 8 plus 6 plus 12. So what do I get here? 90 minus 80 is a 1t, 1t plus 12t is a 13t. Here I get 26. Or my t is 26 by 13, which is a 2. I hope the FBT rule is clear from this particular sum. I will be doing a couple of more sums so that you get a really good understanding about the method, and then you can follow it up whenever you are getting a linear equations in a single variable. Okay. Now you have the next sum. X plus 2 by 6 minus 11 minus x by 3 minus 1 by 4 is equal to 3x minus 4 by 12. I have taken this sum from R.D. Sharma. Now, let us start with the F-B-T method. First one, fractions. Are there fractional terms? Yes. Is there only a single term on the LHS and single term on the RHS? No, I have got multiple terms. So what is my next step? I will take the LCM of all the denominators. What is the LCM of 6, 3, 4 and 12? It is a 12. I will multiply every single term on the LHS and every single term on the RHS with my LCM. Okay. So I get 12 into x plus 2 by 6 minus 12 into 11 minus x by 3 minus 1 by 4 is equal to 12 into 3x minus 4 by 12. Now, second step, open the bracket. So I get 2. So I get here 2x plus 4. Okay. Now this is a slightly trickier one to open. So let me just write it down. This is minus 12 into 11 minus x by 3 minus 12 into minus 1 by 4. Okay. That is equal to 3x minus 4. My opening of brackets is not over. So 2x plus 4. Now I have a single denominator here. 4 minus 44 plus 4x, because it is a minus 4 into minus x. Minus 12 into minus 1 by 4 should give me a plus 3 is equal to 3x minus 4. So what is my next step? Now all the brackets have been removed. I have to transpose all my variables to LHS and the constants to the RHS. So I get 2x plus 4x minus 3x. So my variable terms are gone. My constant terms, minus 4, because already the minus 4 from the LHS, plus 44 from the LHS, and a minus 3 from the LHS. So now you have 2x plus 4x minus 3x, which is a 3x. Minus 4 is a minus 8 plus 44 minus 3. Minus 8 plus 44 gives me a 36. Minus 3 will give me a 33. So what is the value of x? The value of x is 33 by 3, which is an 11. Now let us move on to the next sum. This is our next sum. 2 by 5x minus 5 by 3x is equal to 1 by 15. The reason I have taken this sum is to introduce variables into the denominator. Okay, now let us see. Step 1, whether the linear equation has got fractional terms. Yes, I have got fractional terms, and I have got multiple fractional terms on the LHS. So I have to take the LCM. Now what is the LCM of the denominator? The LCM of 5x and 3x and 15 is 15x. I have taken the LCM as 15x. I have multiplied each term on the LHS and each term on the RHS by 15x. So I have got 15x into 2 by 5x minus 15x into 5 by 3x is equal to 15x by 15. And now I will simplify. I get a 6, I get a 25, and I get an x. Or I get the value of x as equal to minus 19. Now we have our next sum. 1 by x plus 1 plus 1 by x plus 2 is equal to 2 by x plus 10. Let us solve it by the FBT method. First step, are there fractional terms? Yes, of course there are fractional terms. Is there only one term on the LHS and one term on the RHS? I have got more than one term on the LHS and only one term on the RHS. So I am going to treat it as multiple terms condition. What is the LCM of all the denominators? The LCM of all the denominators is x plus 1 into x plus 2 into x plus 10. It is a long LCM, but then I am not going to open up the brackets and end up with a strange cubical expression. For the time being, I will leave it like this. What is my next step? I have to multiply each term in the LHS and each term in the RHS with my LCM. So I will get x plus 1 into x plus 2 into x plus 10 divided by x plus 1 plus x plus 1 into x plus 2 into x plus 10 by x plus 2. I have multiplied LCM with the second term, and I am going to multiply even the RHS with my LCM. Okay. Now multiplication with LCM is over. What is my next step? I have to open the bracket. Before opening the bracket, let me cancel out the common terms. It's gone. It's gone. Okay. Now, let me open the bracket. X plus 2 into x plus 10 is my first term. Plus x plus 1 into x plus 10 is my second term. And my RHS is 2 into x plus 1 into x plus 2. Let me open up the bracket. X square plus 12x plus 20 plus x square plus 11x plus 10 is equal to 2 into x square plus 3x plus 2. Right? So, this becomes 2x square plus 6x plus 4. Sorry. Okay. Now, what is my next step? I have to transpose all the variables to LHS and all the constants to RHS. So, what are my variable terms? X square, 12x, 11x, and I have got 2x square and 6x. Right? So, x square plus x square is a 2x square. 12x plus 11x is a 23x. Now let me take the terms from the RHS. I have a minus 2x square and a minus 6x. Okay. Now let me take the constants to the RHS. I already have a 4 on the RHS. What are my constant terms? I have a 20 here and I have a 10 here. So minus 20 minus 10. So what do I get here? 2x square and 2x square got cancelled. 23 minus 6x, and here I have got 4 minus 20 minus 10. Right? So I get 17x on the LHS and minus 26 on the RHS. So that my value of x now becomes minus 26 by 17. This is our last sum for this particular class. I have taken a sum wherein there are no fractional terms. So we have been doing almost the last 3-4 sums which involve fractional terms. So I can explain the FBT method in detail. So let us do a sum without any fractional terms. Now, step 1, are there any fractional terms? No. So I can move to step 2. What is step 2? Open all the brackets. So here I will get 4x square plus 6x plus 9. Sorry. 12x plus 9 plus 4x square minus 12x plus 9 is equal to 8x square minus 8x plus 6x minus 6 plus 22. Now, all the variable terms on the LHS and constants on the RHS. So, what are my variable terms? 4x square, 12x and minus 12x. So 4x square plus 4x square is an 8x square. 12x minus 12x will get cancelled. And from the RHS, I will take a minus 8x square and plus 8x minus 6x. Right? What do I have on the RHS? RHS, I already have a minus 6 and a plus 22. I have to take a minus 9 and a minus 9, which is a minus 18 from the LHS. Okay. 8x square minus 8x square will get cancelled. 8x minus 6x is a 2x. Minus 6 plus 22 minus 18. So, what will I get? You will get on the RHS a minus 2. Or my x value is minus 2 by 2, which is a minus 1. So, whatever be the kind of linear equation in a single variable that you are getting, please follow the F-B-T method to simplify the linear equation and finally arrive at an answer. Okay. So, we have come to the end of our class. We have solved linear equations by using the FBT method. Any kind of linear equation, you are having multiple brackets, multiple denominators, any kind, you can solve using the FBT method. try to stick to the rule as much as possible when you are doing the sums, so that you get into the flow of doing the sums without having to think at every single step. Okay. Now, as I told you, check for fractions. Are there fractional terms? Yes, there are fractional terms. Is there only one term in the LHS and one term on the RHS? If there is only one term, cross multiply. If there are multiple terms on the LHS or on the RHS, treat it as a multiple term condition. Find the LCM of all the denominators. Multiply each term on the LHS and each term on the RHS with the LCM. Second step, open the bracket, simplify the linear equation. Third step, transpose. As a rule, take all the variables to the LHS and all the constants to the RHS. Solve. Now, any doubts you are having in this particular lesson, please feel free to mail me at the mail ID given below in the description box. I will definitely respond to you. And till I post the next video, keep practicing. Bye. Here I have tried to give a flowchart kind of drawing to explain the FBT method. If you are not comfortable with this, please remember the steps. That would be enough. So I have written fractional terms. So if there are fractional terms in an S condition, how many terms are there? If there is one term, you have to cross multiply. Then you have to go to open bracket and transpose. If there are more than one term, you have to take the LCM of the denominators. Multiply with the LCM every single term on the LHS and RHS. Open the bracket, transpose. If there are no fractional terms, you can skip all this LCM step and then go directly to open the bracket and transpose and then solve for x. And as you already know, F stands for fraction, B stands for bracket, and T stands for transpose.